Hi, this is Nalini Elkins with Industry Network Technology Council, and we are here now for the IPv6 Transition Technology webinar, and thank you so much. People are anticipating that I'm going to ask about the sound and telling me that the sound is fine, so that is just great. If you have any problems or anything, please do let me know. Thank you. Thank you. Okay, so let's go ahead and get started. This session is being recorded, so just so that everybody knows. And if you have questions, do go ahead and send them along, and I will get to them as I get a chance at the end. So I believe many of you are familiar with the premise and how the webinar is going. This is a collaborative project between a couple of nonprofits, INTC and IIESoc from the US and India, with funding from ISIF Asia, part of the APNIC Foundation. And we're trying to do IPv6 deployment, in particularly for enterprises, a very different focus than what others have, which is oftentimes just for ISPs or the general population. The problems of large enterprises are quite different. So these are all the classes. We've done quite a few of them. We're into the transition mechanisms. Next week, Michael will do a lab on transition technologies, and that should be very, very fun and interesting. He'll do some, he'll tell you about how all this stuff that I'm going to talk about really impacts you, and talk about where we go from there, and talk about firewalls and what you're going to have to do and so forth. So it should be a lot of fun. So a couple words about me, like seriously little. You guys can read if you want to. I think I've been in the industry for way too long. Still having fun though. Okay. So this is the agenda. We're going to talk about a number of the transition technologies, both at the enterprise level and at the ISP levels, what the benefits and so forth are, and the drawbacks. This is something that you're going to need to use. And so if probably sooner rather than later. And so you may want to have some interest in this. It's a pain in the neck, I know, okay? So what's the problem here? Well, for many years now, we're used to having single stack implementation, but that single stack is IPv4 only. And so that makes, in some ways, things much simpler. And it doesn't mean simple by any stretch of the imagination. I mean, it's not, it's very complicated as it is. But when you add dual stacking and a second stack to think about and do firewall rules for, think about the vulnerabilities, it creates a much more complex scenario. So a lot of people are really thinking, where we want to get to is a single stack again, but this time IPv6. And I have to tell you, when I first started hearing about this, and largely at the IETF, I'm like, there is something seriously wrong with you people. This is not going to happen. You guys are crazy. But it does make things simpler, and I do know people who are trying to get to that level, and I will say, by and large, it's people who have a great deal of I suppose, motivation and expertise in order to do so. Meaning, very large ISPs in particular. There's one in India. There are others. You'll hear Microsoft, Cisco sometimes talk about V6 only implementations. That they're in a very, very different situation than most of us who are out large enterprises. But it will simplify the implementation. Again, that said, I understand that at enterprises, IPv4 is likely to be around for, who knows, the next 20 years in any case, for a very, very long time. Problem is, of course, and v4 natively cannot talk to v6 natively. So you've got to do something. You've got to do something in order to make them talk. If we think a little bit and take a look at v6 connectivity and penetration, you'll see that it's coming along quite well. This is penetration as far as onto the internet. One of the things this does not measure is what is penetration inside private enterprises, which most of you, I assume, are from. And they can't measure it just because it is private enterprises. I know NIST has tried to do some things, but it's only really for internet facing. But if we look, this is something, if we start looking at IPv6 connectivity onto the wider internet, you'll see that some very small countries, Mayotte, I hope I'm saying that right. I wasn't even sure where that was, not to insult anybody, but I was not aware of that little country, which is doing very, very well. Good for them. Is the number one. And of course, India is doing extremely well. But that is because of basically one very large ISP who has a v6 core. I'm sure you are probably all aware that that's Reliance Geo. Then of course, Belgium is doing quite well. The United States is not doing badly in terms of v6 penetration. And this changes all the time. Upward. But many people are afraid that unless ISPs, unless enterprises deploy, then they will become islands of IPv4 in a sea of IPv6. So you can see here, these are the measurements from the World IPv6 launch, and you can see T-Mobile has a v6 deployment, a very large v6 deployment. Geo in India, very, very large deployment. And then, of course, you can see Comcast, and then the Chinese folks. Yes, many ISPs, the very large ones, are IPv6. And even enterprises are starting to move. This is a little survey that we did, and I need to update this because we've gotten more responses now. And even at enterprises, this is just a rough survey we did to just the folks who come to things like these webinars. And I will say that's not terribly small, because even for these webinars, I'm going to say there's probably over 900 people now who have come to one or more of these webinars, and some have come to all the webinars, which is absolutely wonderful. But you can see even for enterprises that many people are getting to the point where most equipment is dual stacked. This is where some of the things that I'm talking about and I'm going to talk about is going to come into play, and definitely the things that Michael will talk about next week, which is the kind of the issues with dual stack, some of the new vulnerabilities, some of the complexities in managing that environment, and then what do you do with dual stacking? And who knows? When I first did this, I think I did it in 2010, I was thinking, oh my goodness, 2030 is so far away. Well, it doesn't seem quite so far away now. So what does it mean to be dual stacked? Well, if you're a single stack, of course, you only have one protocol stack, or one which is either IPv4 or v6. But if you're dual stacked, then you've got multiple. You've got both those stacks, and they'll be on this. They can be on the same interface. They can be segregated also. And so you can see here, you've got this particular my Wi-Fi interface has multiple IPv6 addresses. These are two static addresses. Here's a temporary address. Here's a link local address, and then I've got my v4 addresses. And my router has got a v6 link local and a v4 gateway address. So you can see here that I've got multiple addresses here. There is a direction for the Office of Management and Budget for the federal government to be v6 only. And it does simplify your environment to do that, but still things break. And I will show you some of the things that break when you do this. I do actually support this because it lowers the complexity, how many firewall rules you need to have, how many transition technologies, just a lot of things. It does support this, but it's maybe a little ways out into the future for us. But we can have some fun. We can try doing it ourselves. And so this is what happened when I turned off IPv4 on my dual stacked laptop. And you can see here, you can see right now, as we showed, it was dual stacked. So how do I do this? I go over to IPv4 adapter properties, and I take a deep breath, and I'm like, okie dokie, here we go. And I turn off v4. And so now when I do my display, well, you can see now that I only have v6. And so now, if there are things that are v4 only, then I'm not going to be able to connect. But if, like, the servers or whatever I'm trying to get to are dual stack, why then it will go through v6. So then, of course, the question is like, well, what's going to break and how am I going to get to v4 sites? So let's keep going here. So one of the things that we used to do, and of course we still do, not legacy yet, NAT64. This is the NAT that we use today. And we don't really think of it as being 4.4, but it is. Because what does that mean? It's really translating a private IPv4 address, say your 192.168 or 10 dot or whatever it is, onto a public IPv4 address that can go over the internet. So what are we going to do when we've got v4 only sites for v6 only clients? Well, you can use something called NAT64 DNS64. And so how does that work? Well, here's the RFC for it. And it's interesting. It's called stateful NAT64. So that's interesting. So what are you going to think? The minute you see stateful, you think, so it's going to keep state, which is information about my session in itself. And so if it is doing that, then that's the box that I have to go through in order to do anything. I mean, I can't, I can't use another NAT64 box because he's not going to know about me. So there you go. But that's how NAT works, right? You have NAT is stateful. So let's see how this is going to work. So you've got this v6 only client, which is going potentially over a v6 only network. And then right before you get to the end point, right before you get to your v4 server, your website, whatever it is, that's where you do the translation. So now, remember a while back when I was talking about enterprises becoming islands of v4 within an IPv6 world. That is what I am talking about, is like if things continue in the manner in which we are all going or not going, as it were, then I wonder if this is the scenario we'll get to in 4 or 5 years. I mean, ideally not. Ideally, enterprises move along as well and become dual stack. But this is kind of the nightmare scenario, right? Is that you're an island and you've got to translate. So how does this all work? So NAT64 is going to need DNS64. And so what is that? Here's the RFC for it, 6147. It is an extension to DNS for doing this. And again, you can see for network address translation. So what it does from the abstract, it creates a quad A record from an A record. When it says it's synthesizing a quad A record from an A record, basically what you're doing is you're taking your A record, which is your regular IPv4 DNS record, and you're like saying, I'm going to do some magic. I'm going to apply some kind of formulas, and I'm going to make up this quad A record, because a quad A record is what you need for IPv6. And so because how are you going to get to that IPv6 address, right? That v6 only node, how is he going to know to get to your v4 device? So this is kind of what it looks like. And again, I'm just making this up. These are fake numbers. There's no quad A there's no such address as 2013 whatever. So I take this record and I make up this other record from it, because the idea is you have a v6 only client and a v4 only server, and neither one of them need to do anything in order to communicate, because you're doing it all at this front end box that's outside of there. So okie dokie. And so what I did is I said, well, okay, so I could have put up NAT64 myself, but I said, well, let me find and see if there's a public NAT64 server. And this is the one that I use. And you might just check and see if this is still working. I mean, as I say, it's a public server, and they can take it down or stop supporting it, but you get the idea. You get the idea of what they're doing. This website will give you a bunch of different ones, and just try different ones out and see what works for you. So first thing I wanted to do is so I just picked one at random. I'm like saying, well, okay, what the heck? I'm just going to pick one of these NAT64 servers. It doesn't matter to me which one I use. So I'm going to ping it and see if I can get to it. That's the first thing you probably want to do is this is a free service, and they're obviously not obligated to keep stuff up for forever. So, but I could get to this one, so far so good. So what I'm going to do then is go ahead and I'm going to go to my v6 properties, and I'm going to say, look, instead of using the getting the DNS server automatically, which I would do if I were going to do just regular, just go with my ISP, I would probably just let them tell me what DNS server I wanted to use. I'm going to tell you, this is the DNS server that I want you to use. And so, okay, I'm like, all righty, I did that. so now let me see. So how am I going to know? I'm going to go ahead and do me an IP config all, and voila, yes, I am using the DNS server that I want to be using. Well, so far so good. So then what I'm going to do is I'm going to just go to some V4 sites. And of course, you can be like, well, how do I know what's V4 or not? I mean, as I say, well, all I did was I just did a ping to a bunch of sites to see if they were coming in V4 only, and tried to do a V6 ping to them. And believe me, it doesn't take very long before you find them. Or the other way is, when I first did my V6 only client by turning off V4, just go ahead and go to a bunch of sites. And if you can't get to them, then you know that they're not able to dual stack and they're V4 only. So you can save that. You can say, well, this site, I know 100% I can't go to that. And so I'm going to try that with NAT64. And believe me, you will find many V4 only sites to choose from. I don't want to be like naming and shaming or anything, but I mean, heck, as I say, you all know who you are. So then I took a Wireshark packet trace, because of course I love Wireshark. It's open source, free, and I know a lot of people who I will never do diagnostics without Wireshark. And as I say, I feel that way too. Love that project. Love the guys there. Very, very good. But so I'm starting to do that, and I can see that I'm going to that NAT6 DNS server that I wanted to go to, and so then I tried doing a couple other things. I said, well, let me try doing some things that are V4 only, and that are not going to work through DNS64. And we'll talk about why this didn't work through DNS64. Well, because here I'm trying to go to this remote desktop connection using V4, and what I would have had to do is get that NAT64 bot, get NAT64 installed myself on the other end, and go and using V6. But I think probably, let me see, I probably could have tried to do a V6 only, but that's not going to work. Remember the function of NAT64 is to go from a V6 only client to a V4 only server. So NAT64 does not solve all your problems. You might have other problems, which is this problem exactly, which is I might have a dual stacked client going over a V6 network or some such thing. So to me, this is kind of what I'm talking about as far as complexity. And I just have to tell you, is like even when I'm testing all this stuff out, I get my head spinning and turned around, and they're like, what am I doing? Like, which transition mechanism am I using for what? The other thing that was real fun that I did is I did a little analysis and did some geolocation using that Wireshark trace, and you can see here that lots of CDNs are involved within this. And one of the things is that particular site that I picked happened to be in Berlin, and so you can see a lot of those things. But one of the things that I was kind of curious about is all the different connections. Anyway, you can see what all is used, and it is kind of fun to go ahead and geolocate some of that stuff. So then I'm like, okay, well, let me go back let me go back to use the regular DNS server for my ISP. So then I go back. Remember, I'm still in v6 only mode. And this is what I said, is like, again, it's like, how did I know that I was using the NAT64? Is because I did this. I went to some v4 sites. I remember I'm v6 only, and I couldn't go out there. And this is what NAT64 allows you to do, is go to those sites which are v4 only, which are not dual staffed. And so that's what you can do. So, again, I know when people first started talking about DNS64, NAT64, I'm kind of like, I totally do not need to pay any attention to this, because this is not going to happen when we have v6 only clients. Well, I'm going to tell you, the world is different, and people are doing that. People are testing that. So just a little, just to be forewarned. So now let's talk about some other methods. And I don't believe we are to the point of calling these legacy methods. These are still very much in use, but they have a different purpose, which is you're essentially fencing off IPv6. You're thinking that you have a v4 host or a v4 network. Let me put it that way. You've got a v4 network, and you've got a v6 packet that's going over that, and both ends are v6. So you've got this packet here starting at your client, which is v6, and it's going to go to your server, which also is v6. But how are you going to get over there from a v4 network? Well, what we're going to do is we're going to start doing tunneling. What is that we're gonna go ahead and stick that packet inside, and some of these are actually deprecated and not used these days, but other ones, such as Tunnel Broker, 6RD, CGN, a bunch of those are very much used, and they're used oftentimes at the ISP level. So let's just talk a bit about how tunnels work. So let's say that you've got some host at this end. You can set it up either at the host, but you can set it up at the router too, or a separate box, something like that. And then you just encapsulate and send it over. As I say, from a conceptual level, it's relatively easy to understand. And you can see here, this is something that I did a fair amount back, because you can see that I was doing this on Windows XP, not Windows 10 or anything like that. And you can see that I've got a number of tunneling interfaces. I've got my Teredo, my automatic tunneling, I believe that was used to be called ISOTAP, so on. In fact, a couple of ISOTAP kind of things. And so I've got facilities to do that. If you do it today, you're not going to see those. And one of the things is, because why are some of these methods deprecated? Well, because there have been a number of security issues that were found. Because what you can do is it might be that the embedded address is not, there's no ACL, there's no firewall rules for that. It might be you can embed a packet that's got malicious extension headers, or you can pretend to be a router, send a router advertisement, or you can send packets directly to the decapsulator. You can just craft packets. As I say, lots of lots of fun things to do. As I said, when I was working with people a while back, then one of the things we used to do, which is relatively secure and which used to be something that we would talk about, is using GRE tunnels. And so you can use a generic route encapsulation, and that's done at the router level. You can configure it on the tunnel interface. And we need of course, that has to be a dual stack kind of a host or router. And then you're doing it at the boundary. And you can have some security, because that is secured using IPsec. And so if you're going to do something like that, this is a method you might wish to consider, is using GRE tunnels. But a lot of folks now are really doing something like this. They will have a V6 network. They'll have a V4 network and a side-by-side V6 network. And so what you can have is V4 routes, V4 only hosts going to V4 only applications. Those exact same applications, might be bilingual, as it were. They might also support V6, or you might have V6 only applications. But in any case, if you've got a network that can talk both, then you've lessened your need for these transition technologies, or at the least, really, you've isolated that complexity over into the hosts, and then maybe segregated your V4 only hosts or V4 only servers, if that makes sense. And when we talk about migration technologies, I think we might try and do that later on if there's time. There's so much to talk about. In migration technologies, one of the issues I talk about there is really going from the inside out or the outside in. When I mean inside out, I mean like going ahead and doing your core network, making that a dual stacked or V6 only, heck, and then letting people come in. Probably you'll have a transition time where you've got something like this. You've got multiple networks, but if you do that, as I say, it kind of lessens the complexity of some of these transition technologies. So then again, we get into the point of where are we now isolating the complexity to? If you've got V4 only applications, that's a consideration, of course. And so do you have to rewrite them? It depends, right? If you wrote it yourself, it was a homegrown application, and it was a homegrown application doing its own socket IO, then yes. And don't get me wrong, to me, that's the only kind of application I wish to write, is I do not want middleware. I want to, if I'm going to write it, I'm going to do my own socket IO. Thank you. But having said that, then you better be prepared to do your own maintenance on it and do any kind of conversion. And a lot of people are extremely capable of doing things like that. But, some people, and especially some of the larger organizations who have thousands of programmers, you probably want to use middleware because you want to concentrate on business logic, and which is exactly what people do. Or heaven forbid, the person who was writing these fancy applications and doing his own socket IO or her own socket IO leaves, and you're left with this program that no one can maintain. That, again, unfortunate situation. So, but it is a whole consideration. And in fact, we're going to have a whole survey coming out to people we've been working on about IPv4 about applications and some of the considerations about applications. It's way more than you might think. And a lot of it has to do with operational and deployment kinds of things, like, okay, so do you have the addresses in disaster recovery? How are you doing? Anyway, let me not, that's a whole another session. And it's something that we have been talking about at INTC with a number of enterprises. So just to be expecting, this is one line on applications, but it is one of the most complex areas that you're going to get into. The performance, what are we going to do about impacting one versus the other, and then as Mike's going to talk about, firewall rules. Performance, I'll just touch real briefly. You guys may have heard of something called Happy Eyeball, and that's something that came out, gosh, probably about, I think they were working on it maybe 10 years ago when I was first getting into the IETF, if I recall correctly. Basically, it's a fallback mechanism for the browser. If you can't find a V6 host, it'll fall back to V4. They call it Happy Eyeball. But there is a performance hit, and I think I have a trace somewhere off that. So firewall policies, are they going to be different? Do you have V6 attacks? And again, Mike will talk a whole lot about this at the next session. Let's talk about translation and how does that work. So far, we've been talking about tunneling. That is, you encapsulate one packet inside another. But then some people are like, well, I have a smart idea. What I'm going to do is I'm just going to translate the headers. I'm just going to say, I've got me this IPv4 packet or V6 packets. I'm just going to rewrite the headers so that one talks to the other, because the payload is the same, right? Well, essentially the same, unless you're doing something like FTP, which embeds IP addresses in there. But let's leave that aside for a moment. We'll come back to that. So basically, the idea is that if you've got something which is talking V4 only, then what you do is, depending on what it is, you rewrite the header to go from what you need, and then translate it back if you need to, or not. And so essentially, what we've got to do is convert the header, but you also need some kind of address. I mean, like we only have a V4 address or a V6 address. Where are we going to find this other address? So we got to get ourselves an address, get some routing. And what kind of methods are we going to use? Well, here's one, the SLBPT. This is a translation methodology. And then again, the little thing that we talked about in the very, very beginning, the NAT64, DNS64, that is also a translation technology. And if I'm going to say anything, I'm going to say that's probably the one that's being, as I said, I'm going to go out on a little bit of a limb, because partly because there's not real good statistics I've seen. As I say, people are working on that, and I'm a little nervous. I'm going to say probably this is good. I know there's people working at the IETF on getting some of these numbers. So basically, what's under the hood of these translation implementations? Well, what we've got is something called SIIT, and we'll talk about that in a moment. And so under that, that's the actual technical formulas, if you will, that work under SLBPT or NAT64. And so you've got some kind of device that's doing this. He's got two different sessions. He's got a V6 session and a V4 session, and he's translating from one to the other. So, all right, well, so if I've got me two different sessions, how do I know how to go from one to the other? Well, okay, so one of the things you can do is you can say, well, I can have some static address translation. I can say I got this address, the .44 address, that's always going to translate to this other IPv6 address, and so forth. .45 is this, 65 is this. Well, I mean, you can real quickly see what the drawback of this particular methodology is, right? How big exactly is that table here? And how are we using that table? And yes, I know what my choke point is doing the lookup of those addresses. And, you know, then you get into like, okay, well, I do a binary search. I don't, you know, as I say, I mean, all the problems that go along with doing static addresses, you know, and that's what you got with. All right, you're like, okay, well, I'm gonna get a little smarter. I'm gonna use me dynamic address allocation. So I'm gonna say, okay, so in my NATPT router or whatever, I'm gonna say I'm gonna give a pool of addresses. And so I have these 7 V6 addresses that I can pick from. Obviously, you would give a lot more, but I'm just doing this as an example. And so something comes in on a V4 address at, say, 7 a.m. I'm going to pick the first free one from the pool. And there's my first problem, right? I pick the first free one from the pool. I'm going to give him this. Let's say that he's a real nice person and he says he does his thing and he does a TCP, FINAC, whatever, and he closes the session. And so I'm like, okay, this pool can now return back to the pool. So then somebody else starts the session and then, you know, I do this whole thing. You can see where the problems in this are going to be, right? So say that I decide, well, I'm going to leave me this address open forever, which is not a really stupid idea. Say that you've got a database connection and you probably or possibly don't want to shut that thing off and be making all kind of connections. Now there's a performance hit, you know, which as I say, had done that, been there. Really bad idea is to, you know, to connect to an SQL database and do a TCP connect every time. Seriously bad idea. Because what you can do is like, you know what's going on there. So the problem is like, are you going to run through this pool? How many do I need to have in there? And I'll tell you, I know, to me, like some of the big apps that I've looked at, I'm pretty sure Google and Facebook, some of these folks do this. Trick or trace yourself. It seemed to me like some of these people, it might be, as I say, Amazon. Anyway, just take a look and see what people are doing. Because what they'll do, a lot of these people, is put out like 6 concurrent connections and do different things over each one. One may be sending images, one may be sending ads, or God knows what all, you know, and which is a really smart thing to do also, because you get some real good multitasking going that way. But as I say, it's easy enough to figure out how to go through dynamic address allocations without having any kind of DOS attacks or anything like that. I mean, just normally, you can do plenty of shot myself in the foot scenarios with dynamic addressing. This is nothing new, you know. This is the nature of stateful devices and dynamic addressing. But this is the complexity you get into when you're having to use V6 and V4. This is, as I say, this is nothing, the concepts are really nothing new. It is the current situation we find ourselves in that leads to this. So the header rewriting, what is the RFC for this and what does it mean? Well, here's 6145, stateless PICMP translation algorithm. And you know what, it just occurred to me, I was just yakking with one of the authors of this, and down the road, I hope that we can get some of these folks, send me a quick note. I'll see if I can get some of these folks. We can try and do an experts panel probably at our end of the year connections that we do, and you can ask a lot of the authors themselves. Now, what did you mean by this, and what's the implementation, and so on. But anyway, let's say I interrupted myself in this. So here's your v4 main header, and you have to translate back and forth to this. I mean, as I say, it sounds really easy. Conceptually, you're like, sure, I can do that. But of course, the devil is in the details. So if you're doing just the IP header itself, yeah, sure, you're probably fairly fine. You can't be doing v4 options. There's no facility for that. If you're doing v4 multicast, can't do that either. As I say, we should get it. We can do a whole thing on v4 multicast and when it's used. I have always been surprised to see that it was used far more frequently than it was. But it's basically when you're getting into like reading and this, that, and the other thing, unless you're doing something like broadcast and table news, news distribution, that kind of thing. I believe those folks use this IPv4 multicast a bunch. But when you get into things like ICMPv6 and ICMPv4, ICMPv6 really should have been called an entirely different protocol, because there's so many different messages. And these are some of our friends from before. If you will recall the neighbor discovery business that we did, that particular webcast, you'll remember router advertisement, neighbor advertisement, multicast listener discovery. This is all new, and it's all going over ICMPv6, and so that's not supported. V6 extension headers, again, a huge topic that we have not talked about, and I hope down the road we'll get a chance to talk about it. There's a ton of stuff in extension headers, which is very, very important, and not all of them are supported by SIIT, and some of these, like destination options and hop by hop, there's a lot of current controversy at the IETF about some of this, and as I say, we could spend several hours talking about just that particular statement. In any case, the thing with rewriting is what is called best effort. And anytime you hear best effort, what it really means is I'll do it if I can, and if I can't, probably I'll throw it away, and probably I'll throw it away without letting you know. And there's pros and cons to that statement, of course, because if you go ahead and send an indication that you've thrown it away, well, you have just created yourself a reflector attack, because I can send you all kinds of things you can't translate, and you're forced to send me all kinds of messages saying I couldn't translate it. So this is a very, very tricky area. But as I say, the moment you see best effort, you look more deeply as to what it's doing. So another problem with this whole scheme of rewriting headers is things that are called application level gateways, or the real problem is applications who embed IP addresses. For example, here's FTP, and I don't need to tell you guys how FTP works. This is, here you go. Here's the port command, and it's, what is this embedding? It's my IP address. Here I was going over loopback, right? So here's good old 127.0.0.1 right there. And and you got to do something with it. And some applications, for example, FTP has a facility. You do extended passive mode, and that eliminates embedded IP addresses. But if you've got other applications, possibly your own, you've got to think about this. That whole thing of using or embedding IPv4 or just IP addresses, it will catch you in a number of different ways. And as I say, we'll do a whole slideshow, a presentation, and then survey on this whole area to see what people are doing. The other thing that happens when you have what is called a stateful device is anytime you have a stateful device, which is a device that's keeping state, for example, NAT64, SLBPT, or NAT, it's a single point of failure because all your sessions have got to go back and forth through that. And unless you're trying to do something, you can do, as I say, there's hot backup for NAT64, distributing state, all that kind of stuff. Do send me a note if you got, about your experiences with dealing with stateful devices, just from an intellectual and from a more than an intellectual basis. It's something I'm very, very interested in, is how people are doing that, and whether this is as much of an issue as I really think it is. So as I say, I'd be very curious to hear from you guys. So again, you can do some attacks. As I say, this is more than the shot myself in the foot scenario. I can easily start doing this. I can just say, I want this, I'm going to start a session. Nope, I'm going to start another one. Just write take me 5 minutes to write a script to do something like this. This is the old TCP SYN flood, right? As like how easy is that to do? Extremely easy, right? And so again, you want to make sure that because I say this is a known problem, so you want to make sure that your device is capable of defending itself against some of this. Yeah. So then if I can't run you out of the dynamic address pool, well then I can do a resource depletion attack to you and start running you out and telling you about, I want to translate this, that, and the other stuff. So this is where Mike's firewall rules are gonna come in real handy, unless of course you've not got them properly set up. And so that's where some of the bypass stuff comes on. Again, this whole firewall area we can talk about for quite a few sessions. And your translation device needs some access control. These are just things you want to think about if you're going to be implementing transition technologies. Just go through and say, have I done this? Am I subject to this? Have I done that? So to keep going, as I say, we're starting to run a little bit out of time, so I'll go through this. This always takes longer than I think. Okay, so for V6 only networks, you can use this too, 464 XLAT, and this is going to provide some limited V4 connectivity going to V6 only networks. I'm not going to talk about this a ton because I don't think most people are kind of there yet. I'll just tell you a little overview. Of course, it's going to use stateful NAT64. Remember, we know this. This is NAT64. We looked about this before. It's going to use SIIT. We looked at this before too. This is the header rewriting stuff. And so now I'm going to go briefly into some of the things that the ISPs do, which is 6RD, DS Lite, and your ISPs might be doing some of this stuff. That's a question for them, is for you to ask. Again, MAP-T, MAP-E, very heavily implemented, I know, in some of the, I believe, Asian networks. Um, you can do something. What you can do is you can fence things off and kick the entire can down the road. And by this, what I mean is like the people who are saying, okay, let's say the federal government mandates that I've got to have a V6 only connection, or someone else. Someone else mandates I'm going to have a V6 only connection. Then I'm going to fence that connection off. Or if I have a V6 only application, I'm gonna put that in its own, kind of zone, and I'm not gonna deal with the rest of my network. Or I'm gonna let the ISP do it. And believe me, this pool of people has not shrunk as much as we might want. It is shrinking a bit though, because there's always drawbacks to let the ISP do it. Is like, well, what's my performance going to be? What's actually going on over there, and how long can I maintain this particular stance? That's really, really the big thing. Again, as I say, what we are trying to do stuff on is where we feel the pain points are going to be. And a lot of folks who are saying that, well, there's a bunch of folks who are saying, I don't know, whatever, you guys pick. But a lot of the people who say that, I kind of have a feeling, and they're talking about what we think are going to be problems is security, application conversion, and training. And that is what we have chosen to do, because that was what we felt as well. And so it kind of gives you the focus for our, there is some kind of method behind our madness here. So let me take a couple of quick questions. And then, we're getting pretty close to time. Some questions are very easy. Is the slide deck available? Yes, of course. And of course, the recording as well. And I believe one of the other organizers has told you where it is. So there's some interesting questions. Okay. Anywhere where one can find what CPU, memory, bandwidth requirements, and so on might be needed for tunneling, like setting up Hurricane Electric's tunnel broker. Super, super good question. And you know what is like, maybe send a note to us offline if you want to work with us, because I'll tell you something. We have tried putting up Hurricane Electric, just the tunnel broker, and we've had some problems using it behind NAT, and I believe they told us even that you needed a public address. But we're happy if somebody wants to take that little project on, we'd be happy to work with you on that, because those are super good questions. And if anybody has managed to do it not from behind a NAT, we'd be real curious about how you did that as well. So yeah, just contact us offline. We're happy to work with you. All right. So this is another super good question. Subtracting out mobile implementation, how well deployed is IPv6 in the United States? I have yet to find many customers that are even talking about IPv6, let alone running it. And all I have to say is, you bet. Now, one of the questions here is, what do you mean by customer? And if you mean enterprises, 100%, that's 100% true. And what I'm going to tell you is just my gut feel for what people are doing. And I'm just going to say gut feel because I talk to a lot of people. I talk to a lot of people all the time about a lot of different things. And I'm going to say my gut feel for what the Fortune 500 and Fortune 500 level companies in the United States are doing. And I am very unhappy to not have numbers about this, but what my gut feel is they're at least dual stacking their web servers, probably 50%. and I'm going to say 50% are probably at least doing that. Some people are doing more, like, for example, like customers who are like, okay, I got a new data center I'm spinning up, I'm going to dual stack that. Or some people say, I've got this particular environment and I'm going to dual stack that. This is, again, another super good area that we would like to work in. NIST has some statistics on, but web facing only. You know, what is your web server doing? What is your DNS server doing? Do you have a mail server that supports IPv6? And this is for a ton of enterprises. And I, as I said, there's stuff I know NIST is going to be thinking about and wanting to do. And there are some background conversations going on about this. And we also are having conversations, because the problem is private networks are just that, private. You see what I'm saying? And people are quite reluctant to say what they're doing. I've even had one customer a long time ago who got into this, and I'm going to say probably close on 10 years ago. It's getting me that long now. And they told me, because they were talking to me, they told me, I don't want you to be talking about us because we feel this is a strategic advantage. And I've never said, you know, of course, I mean, you're not going to, you know, you'll have to torture me to find out who it is. But I'm telling you, some people felt that way a long time ago. And I think they were pretty smart. I don't know that we're headed any other way. It's going to be a question of time. And that's all I'll say. Having said that, what that time span is, whether it's 10 years, whether it's 20 years, whether it's 50 years, I have no idea. I don't know, and I'd like to get some good numbers. And by good numbers, I mean, for this particular question, what is actually going on inside enterprises? And I don't believe any of the numbers that I've seen, frankly. So, okie dokie. Well, thank you guys so much. And we're running out of time now. In fact, we have run out of time. And so thank you again. If you have questions, do feel free to reach out to us. So, okay. And hope to see you at Mike's presentation next week then. Thank you so much.